jet parameters. Jet parameters. Jet parameters. The equation in the jet parameters, what we'll do here, we'll take the v1 v2 yes as a dependent variables, and the i1 i2 as a independent variables. Independent variables. So then we'll write these equations of these jet parameter equations. Those are v1, which is equal to z11 i1 plus z12 i2. v2 is equal to z21 i1 plus z22 i2. These are the jet parameter equations. Here you can see this thing here, v1 v2, this one what it is, a dependent, and this values depends upon i1 i2 are called as a independent variables. Now I can express these parameters in terms of matrix form. I can say this is v1 v2, which is equal to z11 z12 z21 z22, and this is what, i1 and i2, So this parameters we can write it as, we can treat it as v matrix I'm writing, which is equal to what I can say, this is z matrix into what, I matrix. V matrix equal to z matrix into I matrix. We can simply indicate this thing. Z matrix means that is a z parameters box. Whole thing we can indicate with z parameters simply. Now let us find out this z parameters one by one here. What I can say here, z11. How to get the z11 is a z11. How to get the z11 is a v1 by i1 when i2 equal to 0. So it is v1 by i1 when i2 equal to 0. And see this units of this thing, v1 by i1. So this is voltage by current form now. So I can say this units are what, ohms. And so what I can say, this is z11, I can write it as what now here, v1 is in port 1, the input I can say, v2 is the i1 is a port 1 current. So what I can say, this as a driving point input impedance, driving point input impedance we can say. Next, z21, what z21 now, tell me here, this one v2 by i1, v2 by i1 when i2 equal to 0. Now what's the units are here, also ohms only. Yeah, so what I can say, this is v2 is a second port, i1 is a port 1. So what I can say here, The units are in the form of ohms, that is impedance. But what type of impedance it is? We can say from 1 to 2. We can say this 1 to 2 is called a forward. 2 to 1 is called as a reverse. 1 to 2 is happening or not? That means port 1 to port 2 is happened. Port 1 to port 2 is happened or not? So that's why what we can say here, 1 to 2 forward, 2 to 1 is called as reverse. So what I can say, this is a forward transfer of impedance in a forward transfer impedance. Next, Z21. Tell me Z21, sorry, Z12. Z12. Tell me Z12 is a V1 by I2 when I1 equal to 0. So what the units are? And what the units are here? Ohms. And so what I can say here, is a impedance now one to other, so we can transfer of impedance, we can say. So a transfer is happening, or a transfer, and from weight to weight is transfer is happening 1 to 2 or 2 to 1. 1 to 2 or 2 to 1 is a transfer is happened. 2 to 1. 2 to 1 we can call this as what? Reverse transfer impedance. Reverse transfer impedance. Next, Z22. What is Z22 now here? V2 by I2 when I1 equal to 0. And what's the units? Ohms. Now tell me what I can say here. Port to second port impedance now. So what I should call this as a driving point. Output impedance. Same port voltage with same port current, we can use the word of driving point. Other port we can say transfer. And see the transfer from way to way. 1 to 2 is called as a forward, and 2 to 1 is called as a reverse. Simply same port voltage with same port current, we can use a driving point. Yes, if it is a one port to other port, then we can use the word of transfer. Right. Now you can see here, if I call this is V1, this voltage, I can say simply say this is one KVL equation, and this is also one KVL equation only now. Can I develop the network for these equations? We'll develop the network for these equations. So tell me this equation, how we can develop it now here. We are writing this thing. The network for this equation. So this KVL equation we can replace with Thevenin equivalent, I can say. Input is voltage, output is also voltage. Thevenin equivalent. Both are Thevenin equivalents. So we can say this is how we should develop now here. Here this is my port 1 here. This is the port 1, and I can say this voltage V1 and this current is what, I1, and here this is the second port, I can call this as a V2, and this current I can say it as a I2, I can say. Now tell me this equation, first equation. See this equation, V1 is equal to Z11 I1 plus Z12 I2. So how we can develop this equation now here? V1 is equal to Z11 I1 and plus this should be also voltage only now. So this should be what now here? Z12 into V2. You check it now simply if you apply KVL to this equation. So tell me what the equation we can get now here. V1 is equal to Z11 I1 plus Z12 V2. Sanjay, welcome. Next. So tell me this other equation, second equation we should develop now. This if I call this as a Z22 if I say. And this voltage I can call this as what now here? This is Z22 and this I can call it Z21 into V1. Apply KVL to this loop now. Check it now what you will get. V2 is equal to Z22 I2 plus Z21 into V1. Isn't it? These are the equations. These are the equations are not Z parameter equations. Right. Now we'll see the condition for the symmetrical condition and reciprocal condition. We have seen now symmetric condition is V1 by I1 is equal to V2 by I2. V1 by I1 we used to call this as a Z11 and this I can call it Z12. So from this what I can say here, if Z11 is equal to Z22, Z11 equal to Z22, this ratio now, then we can call this network, what I can call this network is a symmetrical network. Then we can call this network as a symmetrical network. Next, and a reciprocal. And see the reciprocal condition is V1 by I2. I can say Z12 equal to Z21. That is a reciprocal condition. So what I can say, Z12 if it is equal to Z21. If this condition satisfies, then we can call the network as what? Reciprocal. Then we can call the network as a reciprocal, I can say. Isn't it? So this is about what it is a Z parameters. You can see here, and to get the Z11, Z12, Z21, what we need to do here, we should make the I2 equal to 0. What is I2 is a second port current is 0 and this current is 0 now here. And next, to get this thing we should make the first port current is 0 now. We should make the I1 0, I2 0, we should do or not? I1 0, I2 0, current is 0. When the current will become 0? When we did open circuit, isn't it? So that's why these are also called as a open circuit parameters. These are also called as a open circuit parameters. Next, you can see the units now. Here what the units are? Ohm. All these units are ohms now. So this is the form of impedance we can say, isn't it? So that's why we can also call them as a impedance parameters. We can also call them as what? Impedance parameters. Right. This is about the